Let's talk about strings. So up to this point, we have looked at several primitive type variables. And remember, primitives are the variable types that are built into the language that are only capable of holding a value. So kind of a very simple variable form are our primitive types. Byte, short, int, long, float, double, char, boolean, those are our primitives, okay? We talked about those last time, or 2 times ago, or whenever we talked about those. Now, when we talked about variable types, we said there are 2 different kinds of variables. There are primitive types, and then there are object type variables, okay? A second kind of variable. Now, object type variables, some of them are built into the language. Others, we are given mechanisms for creating our own. So we get to create our own variable types in Java. We're not going to do that yet. A couple of classes will be doing some of that, but there are some object types built into the language. So what differentiates a primitive type to an object type? So primitive versus object. Oh, you can't see? Oh, how long until you were going to tell me that? So is this water safe to drink?
Of course it is.
It's always
It came out of my truck. I keep a case in there so it's always cold in the wintertime.
Can we see it now?
Yeah,
All right. So primitive types versus object types. We mentioned that primitive types are built into the language and can only hold a value. So primitives built into the language and can only hold a value. Okay? Objects, at least initially, the ones we're going to be looking at, are also built into the language. Okay? Then we have mechanisms for writing our own objects. But for right now, we're going to say these are built into the language as well. And can hold 0 or more values and potentially do more. So think of them like super variables. Okay? So primitives, very simplistic variables, allow us to just hold values. Objects are super variables. They allow us to hold more than one value if it makes sense. And they also allow us to do other things. And we accomplish those other things through things called methods. All right, so let's talk about methods. A method is a reusable chunk of code that takes 0 or more inputs, and I'm going to put in parentheses, these are called parameters, 0 more inputs, and produces and potentially produces an output. Okay, reusable chunk of code that takes 0 or more inputs and potentially produces an output. Its purpose is to allow us, I don't know if this is even good, but whatever. Its purpose is to allow us to write something once and then use it over and over again. Okay? So we write a method once that solves some problem. And then we can call upon that method multiple times whenever we need to solve that problem. Make sense? Real life example of this, if you like making smoothies, you probably own a blender, right? So you can make smoothies in a blender. Well, every single time you want to make a smoothie, do you go out and buy a new blender? You bought one blender, the blender method, and this guy knows how to blend smoothies. You put different kinds of fruit in there. You know, depending on the size of the blender and the power of the blender, there's some sort of limit on how many things you can put in the blender, right? But you put 2 or 3 different kinds of fruit in there, a little bit of juice, those are your inputs, right? Okay, maybe yogurt, depending on how you make your smoothies. You know, you get what I'm saying. So you throw your inputs in there, you push the button, you say go. And the blender method spits out smoothie. That's your output. And every single day you can use that same blender that you bought at Target 5 years ago to make your daily smoothie, right? That's the real world example of a method. All right, so methods. We write it once, so it solves a problem that we're interested in, but it solves it generically. For instance, you don't just walk up to your blender and say, give me a smoothie. If you want a banana strawberry smoothie, you have to put bananas and strawberries in there, right? But if the next day you want blueberry kiwi, I'm going to run out of those fruits pretty quick, blueberry kiwi smoothie, you have to put different inputs into the blender, okay? The blender still does the same job. It blends it all up, but it's going to give you a banana strawberry on the first day and a blueberry kiwi the second day. Make sense? Okay, because you provided the same tool, the same method with different inputs. And based on those different inputs, it produced a different output. Make sense? Okay, that's what a method is. All right, write it once, use it multiple times. Okay, so we are going to learn how to write our own methods. And then for your homework assignment, you're going to write some really hard methods. And you're going to hate me. And I'll probably laugh in front of you. I'm actually thinking hopefully I can solve the homework assignments. Really hard. All right, so we're going to write some of our own methods. But first, before we start writing our own methods, we want to learn about some methods that already exist. And we're going to look at these through the lens of a very important object type that's built into the Java language called strings. I often will say that Java is a string-based language. I think you can say the same thing about C#. I don't think that the folks at Sun Microsystems specifically advertise Java as being a string-based language, but I like to call it a string-based language. And what I mean by that is, in Java, if you can get something into the format of a string, you can pretty much do anything with it. Strings are very, very, very malleable. So that's a fun word to say, malleable. Okay? They're very malleable in Java. So if I have something stored as a string, I can turn strings into numbers. I can do anything with it. I can turn a number into a string. I can turn a string into a number. Very, very malleable. All right? So Java, string-based language. Now what's a string? A string is an opening double quote followed by 0 or more chars followed by a closing double quote. Okay? So this guy, double quote, no spaces. This is the empty string. Very important. We use the empty string all the time. Very important tool. This is the string hello. That is the double quote followed by HELLO, 5 individual chars, closing double quote, and we can store this inside of a variable, maybe called S. So that's how we create strings. Okay, now I'm going to show you something, then I'm going to unshow it to you, just so you know where things are going. The equivalent to this line is to say string S is equal to new string hello, like that. I'm not going to explain this to you today. When we write our own objects, well, actually, when we start using other kinds of objects, I'll explain it then. For right now, we're going to appreciate the fact that Java treats strings as if it is a string-based language. So Java gives us a special syntax for working with strings. That is, it makes strings kind of act like primitives. Okay? Now, what's funny about this, just from a teaching perspective, pretty much every beginning programming class teaches strings as the first object, because they're very important. That's the first object type we show in the class. And in Java, as well as C#, strings are the only object that don't follow the normal object rules. So the very first object we teach you is a special case. Okay? That'll make more sense when we talk about the other objects, and I tell you about that, but I'm kind of foreshadowing. Okay? So strings are a necessary first object to teach you because they're really powerful. But fortunately or unfortunately, depending on which side of the coin you're on, Sun took some liberties with strings to make them easier for us to use, but harder for us to learn other objects because they don't act the same. Okay? But I'll fix that. I'm a genius. It'll be fine. Okay. I only have to stay 10 minutes ahead of you guys. So as long all right. So here's how we define a string. So let's just look at strings in general. Come back into Eclipse over here. We'll say string s is equal to hello. We'll say string s2 is equal to the empty string. Okay, good enough. And then we'll say system.out.println s, system.out.println s2, system.out.println Bob. Okay, so this is a variable definition. We have variable type is string, variable name is s, followed by the assignment operator, followed by the value. This is following the exact same syntax as defining an integer. Variable type, variable name, assignment operator, value. Make sense? Every single variable you ever define will always look like this. Okay? Now, what comes after the equal sign is the value. And sometimes values will look a little different than you expect. More foreshadowing. Okay? But for right now, strings look a lot like primitives. But they're not a primitive type. Very important caveat. Strings are not primitives. Certainly not by my definition, that primitive types can only hold a value. The strings certainly can do more than hold a value. We're going to see that today. We better see it today because your homework relies on it. All right? So, string s is hello. String s2 is equal to the string that contains nothing. That guy is a string, but he's a string that contains 0 chars. Okay? Then we'll go ahead and we will print out the value of s. What's s? Sort of kind of a trick question. I'm kind of training you to how to resolve things. What kind of animal is s? Okay. Go one more level up. S is a variable of type string. Variables hold values. What value does s hold? Hello. Now, that actually, I'm going to let you get away with that for right now because I can't teach you the real thing yet. That actually isn't true. S does not hold hello. S actually holds a memory address, which points into memory where hello lives. Okay? Well, you didn't hear that from me yet. Okay? For right now, S holds hello. Okay? S holds hello. Okay? When I throw pointers at you, that's when we're all done. That world's over. All programmers say pointers are the hardest thing. And they're trivial. I don't even get it. So easy. But you guys will hate me. All right, so the really funny thing is when all the Java textbooks say pointers don't exist in Java, and then I sit up here and prove to you that everything in Java is a pointer. Why make you spend $200 on a textbook that lies to you, right? All right. So S is a variable. Variables boil down to value. So S boils down to the value hello, which is a string. So this will print out hello. S2 is a variable. Variables boil down to their most local definition. S2 is defined right here, and its value is the empty string. So this will print out the empty string, which will look like an empty line. It'll print out nothing and press enter. So getting back to something she said at the beginning of class, print ln, it prints something to the screen and then presses enter to kick it down. If you don't want to kick it down a line, you can just stop at print. Okay.
That's going to be my question to you because work just print. And I was like,
Yeah.
okay. Well, you know.
But if you print something and you print something else, it'll be right next to it. It won't be in one line down. Yeah. So print doesn't press enter. Okay. Print ln displays something and then kicks it down a line. All right. Both are solve different problems. Okay. And this last one, this guy is not a variable. This guy is a literal, a hard-coded value. Literal is a fancy way of saying hard-coded value. So this guy is the literal Bob, which is of type string. Okay. So this guy is going to print out hello, followed by a blank line, followed by Bob. There's our hello, blank line, Bob. All right. So we're cool with strings in terms of creating them. Okay, now let's see what kind of magic trick strings can do. Because remember, I mentioned that objects are built into the language, can hold 0 or more values. For strings, we can look at it a couple different ways. We can say strings hold one value, that is a string, or we can really look at it as strings hold a collection of chars, right? So really, strings hold many values, a whole bunch of char primitive types. Make sense? And stores them for us in this nice package that we look at and say, oh, that's a string. Double quote, bunch of crap, double quote. Okay? So we're past that, but now we have this part. Potentially, they do more. What is this more that strings can do? Well, as opposed to, remember that, I'm going to even capitalize this, for primitive types. Primitives can only hold a value. They don't get the more. Okay? Primitives don't get this guy, the more. Whatever that is. So let's look. String methods. Okay? So methods, as we pointed out, reusable chunks of code that take 0 or more inputs and potentially produce output. Potentially. Not all methods return a value. Some of them do. Some of them just do something. Make sense? Okay. So I guess so the blender that returns a value. Put fruit in, push button, gives you a smoothie. That's a method that returns a value. Okay. Let's see. Something that doesn't return a value. Well, here, put shoe on. The put shoe on method that's in our head, the ability we have to put our shoe on. Once our shoe's on, we don't get like a cookie, right? We're just good to go. The shoe is now on. It doesn't give us a receipt. We're done, right? It solved a problem. We employed our get shoe on method that we've memorized over the years. Some of us still tie our shoes. Some of us, like I like to keep them loose enough so I don't have to bend over to tie them, right? So I've taken a shortcut method. I re-implemented the put shoe on method. But in any case, we use that method on a daily basis to put our shoes on, but we don't get anything in return. Our shoes just on. No receipt, no cookie, no nothing. I wish it gave me a cookie. But in any case, I got cookies today, though. I got free cookies. And a questionable bottle of water.
I swear, I have another one. I swear. I would not do that.
I'll drink the water.
I'd ask somebody the same question.
I told you about the last class. I don't care anyways, but some of these guys were bringing pots of tea to class, and who even knows what they were putting in that crap? Where's my tea? But where's my Portillo's? That's what you told me 2 classes ago and you skipped. That's a guy that's not interested in getting a good grade. I bragged about you on Facebook. The first week he said, oh, it was a 4-hour class, but hey, I got Portillo's coming. Then they have a half an inch of snow last week. Oh my gosh, can't come. It's like, oh, this week I'm gonna get Portillo's. Shows up 20 minutes late. I'm thinking, oh, must have had to go through Portillo's. The saving grace here was the pile of cookies and the questionable water. All right. So, see, even at 9 p.m., I'm still going strong. Having you laughing? Oh, man. Wait till you see this assignment. All right. So, methods. Reusable chunks of code. Some of them return values, some of them don't. Strings have some extra magic tricks in them. These are called methods. Now, methods actually come in 2 types. We have instance methods and we have class methods. All the string methods are instance methods. Something we're really going to drill into you over the next several classes is the difference between instance methods and class methods. I'm actually not going to get into the details of it today. A, we only have an hour left, and B, it's not really important for you to know it for your assignment. So, kind of those 2 things. But I'm telling you from a trivia perspective right now, all the methods in the string class are what are called instance methods. And being an instance method tells us how do we write it, and these are all written for us already. But more importantly for us with strings, how do we call it? How do we call the method? All right? So, first important method to us for strings is a method called length. The length method, well, here, before I even do that, let me just quickly, show you the syntax for a method. Syntax for a method is return type, followed by method name, followed by open parenthesis, followed by parameters or inputs, comma delimited list of inputs, followed by closing parenthesis, opening curly brace, closing curly brace. Do stuff. Okay? So that's the syntax for a method, and we're going to write some of our own methods today. So string methods, we have a method, the method name is length, its return type is int, and it requires no inputs. It still has a parameter list. It still has this open and close parentheses for the inputs, but it does not require us to give it any inputs to work. Unlike our blender, which expects some fruit. The length method doesn't need anything to do its job. Okay? And what the length method does is this returns the number of chars in this string. Let's say in the calling string. Okay? So that's what the length method does. And let's go see this in action. So define a couple strings here, S and S2. We'll go ahead and print out S, which we saw last time prints out a hello. And then we're going to call S's length method. So we're going to print out S dot length. So we are using S to call his length instance methods. Instance methods are always called using an instance of the class in which they were defined. Don't worry about that too much right now. That will be drilled into your soul after starting next week. All right? But we call instance methods using a variable of the type of the class. So since length is a method in the string class, we call it using S dot because it's an instance method. So this is calling S's length method. And S's length is 5. the number of characters that are in S. Hello is S. 5 is S's length. Make sense? I'll put a third line out here, and I'm going to print out S2's length. That is the same length method. This is a blender. Okay? So S went to target, bought a blender. S2 went to target, bought a blender. These are identical blenders. Okay? But S's blender makes the stuff that S puts in it. Makes the stuff at S's house. S2's blender makes the stuff at S2's house. All right? Now, it just so happens that this blender knows how to spit out how many characters are in its owner. Starting to lose the analogy a little bit. Okay. This guy knows how to spit out to us how many characters are in its owner. S's length method knows that S has 5 characters. S2's length method knows that S2 has how many characters? S2 is defined right there. How many characters are in there? None. It's the empty string. It's still a string. It's a string that contains 0 characters. So S2's length will be 0. Hello? 5, 0. This is S. This is S's length. This is S2's length. Make sense? All right. That's our length method. So the length method tells us how many characters are in a particular string. The string that we called it with. If you look back here, I referred to it as the calling string. Whatever string we called the length method with, it is that string whose length it returns. Make sense? Next method. Method called charat that returns a char primitive type. Go ahead.
In S2, string S2, we can provide the space in between them. Then
So if you want to do this, like that.
yeah.
Yeah. Now it's no longer the empty string. Now it's a string containing a space that has a length of 1.
Length of 1, right?
Yep. This will be length of 1. Okay. Now it'll be the length of 2. Make sense? Okay, because remember, a string is a collection of chars. So a space is a char. Question mark is a char. The number 1 is a char, as long as it's the char 1. That is single quote 1, single quote. Okay, so I can have a string containing a 1. 1's only a number if it's a number. And we'll see plenty of examples of that. Okay, so now this guy has a length of 3 because I put random crap in there. Make sense? Charat method. Name of the method is charat with a capital A. This is pretty common naming conventions for methods. Typically, they start with a lowercase character, and the method name kind of tries to describe what the method does. Typically, this is more naming convention than like some sort of rule. But the charat method gives you the character at a specific index in the string, in the calling string. So it's called charat. It returns for us a char. And as an input, it requires us to provide it with an index, a position in the string. Okay? So this guy returns the char at the specified index of the calling string. Okay, now let's talk about this index for a second here. So I'm going to go back to this previous slide where we were talking about strings. I'm going to create for us a string. All right, so if I say string s is equal to hello, what that actually creates for us is a structure that looks like this. Okay, that means s holds 5 separate char characters, five separate chars, h and e and l and l and an o, and it stores them in some sort of interesting way that we don't need to understand right now. It just does. Okay, but it happens to organize those guys in order such that the length of s is 5, but s is indexed starting at bucket 0. So the very first character in s is at bucket 0. The second one is at bucket 1, bucket 2, bucket 3, bucket 4. So the last one is at its length minus 1. Length is 5. Last legal character is at bucket 4. 4. This guy, there's 1, 2, 3, 4, 5. 5 characters in that string. But the indexes are 0, 1, 2, 3, and 4. Because it's 0 based, starts at 0. Okay? So the charat method allows us to say, I want the character at bucket 0 in S, which will give us an H. I want the character at bucket 1 in S, which will give us the E. I want the character at bucket 4 in S, which will give us the O. That make sense? So now, I changed my third print statement here. So the first one prints out S. Second one prints out S's length. The third one prints out whatever character lives at position 0 in S. Or I usually refer to them as buckets. Bucket 0 of S. Well, S is the string hello. Bucket 0 is the very first char, which is an H. So this line right here will print out the char H. Okay? Because this particular blender takes one input and spits out a single char. Charat method takes one integer as an input and gives us a char as an output. That is the char that lives at this position in the calling string. So this is going to give us an H. This will give us the E. What will that give us?
Error.
Error? Which makes more sense, 0 or error? An error exception? Yeah, I mean, this isn't, we don't have 11 buckets. S has 5 buckets, labeled 0 to 4. So any number greater than 4 is going to lead to trouble. Right? It's going to lead to trouble with S. So this is going to give us an array index out of bounds exception. String index out of bounds exception. Telling us bucket 11, there is no bucket 11. All right? Makes sense what charat does? The really important thing to gain from, to understand with charats, because these are really important methods. I know it seems simple right now, but we're going to be using charats a lot. We're going to use a kind of the opposite of charat as well, called index of. It's another method that we'll use that I'll show you here in a few minutes. But the real important points to remember about strings. Their length is the total number of characters, the total number of chars that are in the string. The string is indexed from 0 to length minus 1. So if there's 5 characters, legal buckets are 0, 1, 2, 3, and 4. Length minus 1. Make sense? Okay. Very important. Now, let's say I want to print out each character of S. 1 character per line. Well, I can do a whole bunch of print statements, right? Say system.out.println s.charat0, system.out.println s.charat1, system.out.println s.charat2. Let's make s a little bit longer. Probably a for loop, right? Why a for loop? For loops lend themselves to what kind of problems? Counting problems. How many times do I need to spin through this this string in order to get all the characters? Love that answer. The answer is not 5 times. The answer is s.length number of times. Okay? Understanding that's going to be really important in a second when I show you a method. We're going to write our own method that does this. In this case, we can look at this string and we know there's 5 guys in there, right? But if we want to write code that generically loops through any length string, rather than hard code in a 5, why don't we just ask the string to tell us how many characters it has? How many characters are in S? S.length number of characters, indexed from 0 to s.length minus 1. So for int I is equal to 0, the first legal bucket in our string, I is less than s.length I plus plus. This is our for loop pattern for looping through every character in a string. Notice that we go as long as I is less than s.length, which is the same thing as saying it's less than or equal to s.length minus 1. Okay? So when we had before, when we said I is less than 10, that went 0 to 9. If s.length is 5, this will go 0 to 4. The legal characters in S. Make sense? So we'll start I off at 0. It's the first legal position in S. Bucket 0, all strings. That's true of all strings. Keep going as long as I is less than the length of S. Add 1 to I each time. What are we going to do each time here? We're going to print out the current character. Where is the current character? S dot charat what? I. S dot charat I. So the first time I is 0. Second time I is 1. Third time I is 2. Fourth time I is 3. Make sense? I changes. So we want to make sure we put the variable there so that we're getting a different character each time. If we just put a 0 there, we're going to get H 5 times. Because this loop will take us through here 5 times. You know, this loop has nothing to do with the string other than the fact that we're going to loop through the same number of times as that string has characters. So if I say print out whatever's at bucket 0, I'll get H 5 times. But if I say give me the character at position I each time through that loop, now it'll give me the individual characters. Make sense? And because I wrote that code generically, I can come up here and I can change hello to elephant. And I don't have to change any of the rest of the code. Now it prints out elephant. Even though elephant has 8 characters and hello had 5. I didn't have to change my code because I wrote it in terms of whatever S's length is, not hard coding in a 5. If I had hard coded in a 5, I would have only gotten part of elephant. Make sense? All right, I'm about to trick you. What's the output of this program going to be? Let me ask you a quick question. Does the empty string have a bucket 0?
Yeah. It does. No?
How many characters are in the empty string? What's the length of the empty string? 0. So the last legal bucket is length minus 1. Is there a bucket 0 in the empty string? There's not. Bucket 0 of the empty string would be an illegal bucket. String index out of bounds exception. So what's the output of this program going to be? Remember I told you I was tricking you. Everything I just told you is true. There is not a bucket 0 in the empty string. If you try to access bucket 0 of S, you will get in this case, since S is the empty string, you will get a string index out of bounds exception. What's the output of this program? Ah, why won't it run?
Because the Boolean expression will not meet.
Because for loops are pre-check loops. For loops are pre-check loops. We ask the question first. For loops and while loops are not guaranteed to run at all. Do while loops, on the other hand, are post-check loops. So we will execute the body of the loop at least once, then ask the question. Okay? So we have to ask this question before we ever try to extract a character from the string. And what's the question? I starts off as 0. Is 0 less than 0? S's length in this case is 0, correct? The empty string's length has 0 characters in it. Is 0 less than 0? It's not. That's false. Since it's false, we just skip right past the for loop. Program's done. So this will do nothing. Okay? You want to see the nice error, you say less than or equal to 0 to force it to go through once, and then they'll say, oh my gosh, bad things. Make sense? All right. So, length method makes sense? Charat method makes sense? So length tells us how many characters in a string. Charat method tells us what a character at a particular place in a string is. Okay? Another method called index of takes a character as a parameter and returns as an integer the index in the string, in the calling string, where the char that we passed it first occurs. So this returns the int position in the calling string where the char C first occurs. And now there's a second part to this that's the most important part to this. And you remember that I said this when you think your homework's really, really hard. Okay? This is a hint. Okay? So this returns the int position in the calling string where the char C first occurs, or a -1 if the char C is not found. Okay? So we can think of index of as a way of looking up a character inside of a string and having it tell us where to find that character. What position, what index in that string can I first find that character? Okay? As an example, we'll go back to hello. We'll do system.out.println s for hello. System.out.println s.index of h. What is the position in S that H first occurs? 0. So this will print out hello because it's the full string. This will boil down to the integer position in the calling string S where H is first found, which is at position 0.
And in Java, it doesn't matter if it was uppercase or not.
It does. Yep. So if I say capital H here, what will it return? -1. Not found. Capital H is not found in that string. Make sense? So our string is all lowercase letters here, H-E-L-L-O. A capital H is not found in that collection of chars. What about an E? One. What about an L? Okay, so L occurs twice, right? But the first occurrence of L is at position 2. Okay, this guy returns the position of the first occurrence of this character in the calling string, or -1 if it was not found. So this is going to give us a 2. Make sense? All right.
How to get the second value?
You can't with this tool.
If there is a huge string with the name, we need to find the name, index of each and every character. Then it's difficult, right?
Well, this tool only allows you to do so much. So if you need to find the last occurrence of something, and I haven't taught you a tool for that, you would have to write some code to do it. You'd have to write a method probably to do it. I'm about to show you how to write methods. But you would have to write the logic to loop through the string, looking at where each occurrence of L is as you walk through the string one character at a time, and keeping track of what was the last L you saw and where it was located. That make sense? We'll even write it. It's not a hard method. So let's talk about methods in terms of writing them. So we're going to write our own method down here. Now, for all intents and purposes right now, for us, every single method we write will always have the word static in front. Just trust me on that for right now. Okay? Remember that conversation about class methods versus instance methods? We're having that next class. I'll explain about the static and non-static then. Okay? For right now, when you write your own methods, you put static in there. Okay? So, always start off with static. Then, we'll have our return type. So, let's go ahead and let's make this guy return void. Okay? That means it returns nothing. Remember earlier when I said what methods do? Potentially produces an output. Okay? Potentially produces an output. And we're going to call this method displaystring. That's the method name. And then we have an open parenthesis, and then a comma delimited list of inputs, or parameters is the object-oriented term for it. And we're going to have this guy take in a single string as a parameter. Okay? So this method is called displaystring. Remember, methods are reusable chunks of code that take 0 or more inputs and potentially return a value. This guy has a return type of void, which is our way of saying we will not be returning a value. That doesn't mean we won't be doing anything, but we won't actually be giving you anything. Remember the put your shoe on method? Shoe ended up getting on, but we didn't give you a receipt or anything as a response. Make sense? All right. So what displaystring is going to do is it's going to print out S, one character at a time, one character per line, whatever the contents of S. So tell me, how many chars are there in S? S dot length number of chars. This guy has nothing to do with it. This is a red scope. This is another red scope. So if I were to do our overlay here, all this stuff is our green environment from our previous slide. And inside that green environment, we have one red environment, and now we have a second red environment. But these red environments are not linked to each other. So this S is whoever got passed into this guy. It does not have access to this. Okay, I could have named this guy Bob. Okay, this is the input that I expect for display string. And I'm saying I expect you to give me a string. I happen to name it Bob here because that's what I'm going to call it by down here. If I name it elephant, I'll call it elephant down here. If I name it S, I'll refer to it as S down here. Make sense? How many characters are in S? S.length number of characters. Okay? So I can write for int I is equal to 0, I is less than S.length, I plus plus, and then system.out.println S.charat I. So now I've written a little method. And this method will take in a string, any string, and it will display the contents of that string 1 character per line. Methods are reusable chunks of code. So I've written this method once, now I can use it multiple times. Now, for right now, the way you call your own methods is using the name of the class. Just to complete the example here, we're going to talk about this next time, so you don't have to worry about remembering this for now. Because this guy has static in front of it when I defined it, it's a class method. The way we call class methods is using the name of the class in which the method was defined. You will have that memorized by the end of this class. You don't have to worry about it right now. It doesn't have anything to do with your assignment. Okay? But for right now, since we made our method static because I told you you had to, we call it by saying driver.displaystring. Okay? Driver.displaystring, and we'll go ahead and pass it S. So we are calling upon the method we wrote, passing it our string S as an input, which will come flying in here, stored in this local variable called S, which we then print out 1 character at a time. That make sense? Now, if I don't use this, what's the output of this program? There's nothing that prints out here. It's a little bit of a trick because we have string S here and it looks like we're referring to an S here. But remember, red environment, another red environment. These guys have nothing to do with each other. They just both happen to live within the same green environment. Make sense? This method is a reusable chunk of code. More importantly, it's also an untapped, I don't know about more importantly, but equally important, it's an untapped resource until we actually call it. Okay? I wrote this method, I wrote this ability, but I've never used it at this point. I'm not calling it from up here. Okay? Something that I should probably mention now. All programs begin and end with main. All programs begin and end with main. Every single Java program will have a main method that looks exactly like this. The only thing it could change is you can name arg something different. You can call it elephant if you want. But it must look like this otherwise. And when you first call your program, when we hit play, what does it do? It calls this guy. And what does this guy say to do? Right now he says define a string name S, set it equal to hello. Okay, I'm done. That's all this program does right now. So there will be no output. On the other hand, if I decide, oh, I would like to use this method that I've created, I can now call that method from within main, passing it a string, and now it will pass that string into that method, and the method will do some work. Similarly, I can call the method a second time. And maybe I pass this guy elephant. Now it'll print out hello and then elephant. There's the hello, there's elephant. The same generic tool, the same method. I wrote the method once, called it with 2 separate strings, and it worked for both of them. Make sense?
And it doesn't matter what the method is, if it's before or after the main.
In this case, it doesn't. Yep. Because this green environment contains both of these, and modernly, let's see, is your background C++ and C?
C.
Okay, that's why you think it needs to be before it. Older compilers, like the C compiler, use what was called a one-pass compiler, which means that as it went through your code, it only went through the code one time to collect the collection of symbols in your code. Modern compilers do a two-pass compilation. So what they do is they go through it once to find out all the names of all your methods. Then they go through it again to make sure that the methods you're calling exist. So from your C background, you probably had to prototype methods, or you used header files. Did you do either of those? Prototype or headers? So in C, what you maybe would have done is something like this.
Yeah.
Okay? You could prototype it up here. Tell it what it will be. You could actually write it later on. You can implement it later on. But you have to prototype it at the top before you actually use it.
Define it first.
Yep, you got to define it first.
And in Java, if it wasn't the top,
It would still work.
yeah, it will work. But how will the compiler read it? Will it go to the method and go inside it, or just read that?
Well, the difference with Java and really all modern languages is it compiles in 2 separate passes. The first pass, so it's called a 2-pass compiler. The first pass, it goes through and reads all your method names. It does some other things too, but that's one of the things it does. So it reads in all your method names. The second pass, after it already has a collection of those method names, which is equivalent to you prototyping your methods, it knows about them. It already read them in. The second pass, it actually goes in and looks at the insides of those methods. And now when it sees display string, it's heard of it because it's already read it from the first pass. Make sense?
So it goes inside only after we call the method. Right.
It goes inside the methods at a time of compilation when you're compiling it. It goes inside on the second pass. The first pass is just collecting the names of your methods. It's building what's called a symbol list. Okay, so the first pass, it's essentially doing what you manually did by prototyping methods in C. Okay, it's going through and saying, look, I'm just going to collect the name of all your methods right off the bat so that you don't have to prototype them up here and write them later. I'll just do it for you. I'll just run through your code real quick, get the names of all your methods, so that the second time I go through the code, when I see you using a method, I will know whether or not you're calling it correctly. Make sense? Okay, so with modern compilers, because it's done in 2 separate passes, we don't have to worry about defining this guy after we actually try to use him. Now, if it makes you feel better, you could certainly put this guy up top. That doesn't break any rules. See what I'm saying? But historically, main method usually comes first. It's more just programming practice, nothing more.
And that doesn't have effect on the program performance if you put the methods on the top.
No. Because your program doesn't look like this. After you compile, the compiler, what does the compiler do? Converts between a high-level language and a low-level language. So in the end, you're going to be left with Java bytecode. And who the heck knows what that's going to look like? It looks like whatever the compiler spit out, right? Think of the compiler like as a super complex method. You throw a string to it, that is your Java source code, and it spits out Java bytecode. Okay, let's hope somebody knows how to read that. That's the Java virtual machine. Make sense? So I would say most programming standards would have main come first. Not because it has to, just that's typically what you'd see. Okay, realistically, we don't really have to worry about this for too long because even though Java is an object-oriented language, we're still using it very much like a procedural language. Pretty soon here, we're not going to be writing stuff like this inside of our driver class. We're going to have this one method here called main, And main's going to be calling our own objects that we're writing inside of other files. Like as an example here is my data structures class from this semester. Notice that we already, there's 3 separate classes here. Here's our driver, and the driver is creating a linked list, which is implemented in these files. Okay, it's an object-oriented approach. If you go back to driver for that class, notice that the only thing that's in here is main. All those extra methods and stuff are someplace else. Remember when we talked about the object-oriented version of the phone versus the procedural version of the phone? Procedural, we see all the details. Okay? We see main, we see all of our methods we're writing. It's all just laying out there in front of us. The object-oriented version of it, though, hides all of those details. Like, for instance, here's our linked list that we're writing in that class. So let's just call that a bunch of code. And it hides it so that when you're out here in main, you're just using it. Make sense? This is the approach, the object-oriented approach. It's more like that object-oriented phone that looks like a phone. All right? So part of the issue is that when we're first learning a language, we're kind of forced into a procedural mindset because we don't know enough yet to start working with it as an object-oriented language. So we just have to deal. All right, so display string method. It's a reusable chunk of code. We call it by saying driver dot, the name of the method, for right now because I told you so. I'll explain it in a lot more detail next class. I just don't want to run out of time. We can call that method multiple times, passing it different inputs as long as the input is always a string, because that's what that guy expects. I wrote this method to expect a single input of type string. So whenever I call it, I must pass it a string. Is that a string? Didn't we already cover this? What's S? S is a variable that resolves to a string. It actually resolves to a pointer, which points to a string. Okay. But I realize it's funny, but it is important that when we're looking at our code, we do understand that we have to resolve this. When we see S here, we know that must be a variable. How do you know that's a variable? Just by glancing at it. How do you know it's either a variable or an error? What about S here tells you that this guy is either an error or it must be a variable? Just by looking at it. I found a little more cookie. Extra surprise. Well, don't get this wrong.
We already defined as before as a string. So.
Here, I'm only going to let you see this one line. Now you don't see anything. This is all you see in the world, right here. How do you know that S must be a variable or an error? But assuming it's not an error, how do we know S must be a variable?
Because it's a method.
S isn't a method. Well, here, I can show you less.
What's the value?
Here, well, I don't want to hear it. There. How do we know that S must be a variable? Can't take away anything else. We're out of stuff I can remove from this example.
Because it's not a string, so it's not.
Well, how do you know it's not a string? Oh, no double quotes around it. Must not be a string. What else must it not be? Okay, how do you know it's not an integer? Because it's not an integer. It's not a 0, it's not a 1, it's not a 2, it's not 274. It's not an integer, right? Okay, so not a string, not an integer. What else could it be? Well, we don't know about pointers yet. They don't exist in Java anyways, if you listen to the books. Okay, so based on what we know, what else could it be?
A method.
Well, it could be a method. How do you know it's not one of those?
It doesn't have those two.
No open and closing parentheses. No parameter list. Okay? Methods don't have to take any parameters, but they must have a parameter list. Like the length method had the open and closing parentheses, didn't take anything in them, but still had them. So, not a method. What else could it be?
It starts with lowercase. That might be the reason.
That's more naming convention. We could certainly name our variables uppercase. What else could this guy be that we know it's not?
It's not a Boolean.
Not a Boolean? Okay, not a Boolean, because it's not a true or false, right? Okay, what else? A who? Substring. Did we talk about substrings in here? See, she's getting ahead of us. I would agree it's not the substring method. In fact, we covered that it's not even a method. Right? Okay, so what else could it be that we know it's not? Okay, not a double, because it's not a double. Good with that.
Double float.
Not a float. What about chars? How do you know that's not a char? S is a char, isn't it?
It doesn't have
Single quote.
Ah, it's not surrounded by the single quotes. Right? Chars have single quote, the char, single quote. So, this guy isn't any of those things. It's not any of our literals. Not a string, not a char, not a number.
It's an object.
Huh?
This is an object, right? It's not a primitive one. Primitive data type.
Well, you don't know that it's an object at this point. Couldn't I have said someplace else int s equals 5? I mean, s is a legal variable name for holding an int. So we know s is a variable because it's not any of the other things. So if you are the Java virtual machine at runtime and you are going through your code and you're resolving each line of code and you come upon this guy, you're going to look at it, you're going to say, what am I supposed to do with this guy? Well, how do I treat him? Well, he's not a string. He's not a char. He's not an int. He's not a double. He's not a method. He must be a variable. Or it's an error, but I can't tell him he's an error yet. I can't tell him it's an error yet. I need to go and first check my environments to see if I have a variable named s someplace, right? And ultimately, he's going to go up there, and he's going to find, oh, yes, we have in our red environment a variable named s that happens to be of object type in this case that holds the value hello. So s is a variable that resolves to its value. And as far as we know, its value is hello. The reality is its value is a pointer which points to hello. But we'll talk about that in a later class. That make sense? Now, there's nothing illegal about us saying int b is equal to, well here, let's just stick it with s for our, so we'll just take this out. There's nothing illegal about this, right? Can't I create a variable named s capable of holding an integer and set it to 5? So in this case, we wouldn't say that s is an object. It's a primitive type. So s is a variable. Okay? Why is this guy upset now? Yeah. I wrote this method to take a string. I'm passing it a string right here. Not so much right here. S is still a variable, but now it's a variable of type int. Make sense? Lots of stuff going on. We have to make sure everything lines up. Okay? That's why it's so important that you spend time reading your code before you just running it, or before you just run it and hope. Okay? You won't learn anything if you run it and hope. Just like playing the slot machines. Sometimes you win. Just keep pulling the handle, and sometimes money comes out, but usually money goes in. Right? Now they've made it more convenient for us with the little cards. We don't really feel like we're losing as much money because it's on the digital card instead of You know, in the old days in the casinos, you had the people there with the buckets of coins, right? Did you know that existed? Buckets of coins. You've seen the buckets of coins at the casinos, right? Are you a gambler?
No, but I've been in, seen for the food.
See, yeah, serious. Same here. I was married in Vegas. My wife and I got married. We didn't elope. We had a wedding there. But I don't gamble at all. I don't play. You know, like I don't know the card games and stuff. I'm not into that. And the slot machines, I just think it's stupid. But I told her I was a high roller on the nickel machines. So like in some of the hotels, they have malls, and outside the mall, she goes shopping and does her crap. So I'm not clothes shopping and stuff. So I sit there and I threw like $20 in to a nickel machine. I made like $600 playing the nickel machine. Told her I was a high roller. I was waiting for the guy to come give us a free hotel room or something. Nobody came. I think they're hanging out near the blackjack tables. Who knows? I think I lost it the rest of the trip. I decided I must be an expert. I actually don't think I lost it all. No, usually when I go to casinos, I sit at the slot machine. I put in like $5 in like the penny machines. You just kind of sit there and go real slow. That way they keep bringing you drinks. Like, oh, only house wine is free? I'm cool with that. After about 6 or 7 glasses, like, okay, I've lost $3. That's a good deal. It was a very economically friendly night, is what I'm saying. 2 bottles of wine, $3.50. Perfect.
Winning.
Yeah, winning. Now let's go hit the buffet. All right. So what was I talking about here? Okay, yeah, so that's why that was an error. All right, so display string. All right, questions about methods. Now let me go into the assignment real quick and just make sure I've given you everything that you need.
That's hard.
This is actually just step 4 of it. There was 3 before. Oh my God. All right, let's talk about each of these methods. And I'm going to try to give you some hints for doing that, okay? So take some notes. Number 1, so you're going to write a method for each of these, 1 through 4. Number 1, you're writing a method called print vowels. So this method should take a string as a parameter, just like we've already written. We've written a method that took a string, right? So this one will be another method that takes a string, and it should print all of the vowels contained in that string, 1 character per line. We currently have a method that prints every character in the string, correct? So we have a method right now called displaystring that takes a string as a parameter and literally prints out every single character in that string, 1 character per line. The print vowels method should print out only the vowels that are in that string. That is an A, E, I, O, U. Okay? Upper or lower case, it should support. Okay? So that means as you're going through this loop, before you just haphazardly print out the character, you need to make sure that you are supposed to print it out by first detecting whether or not it is a vowel, using only the tools I've shown you so far. Okay? Now, I would strongly encourage you to figure out how to use the index of method to solve this problem. Okay? Remember, huge hint on this. Remember that the index of method returns a -1 when whatever you're looking for was not found. Okay? So I suggest you use the index of method. I'll even give you a little extra hint. Okay? I'm just going to write a string down real quick. I'm not going to say anything about it. All right? This may be very helpful in completing your assignment. And if you understand how you might use this string along with the index of method, you might find some of the other methods substantially easier to solve. That is the string containing all of the vowels. This is the string containing all of the vowels, upper and lower case. You might find it helpful to use this along with the index of method, along with your knowledge about that -1 thingy, to solve this question. All right? Let's see, number 2, print consonants. If you figure out number 1, number 2 should be pretty easy. If you do number 1 in a different way than I've suggested, you might find number 2 to be pretty mind-numbing. Might have a lot of if statements. If it's an A, if it's an E, if it's an I, if it's an O, if it's a U, if it's a capital A, if it's a capital E, if it's a capital I. That's only somewhat annoying for vowels. A couple more consonants, right? Upper and lower case, of course. I would strongly encourage you to use index of for both of those. Okay? It's 1 and 2. Number 3, print digits. Should take a string as a parameter and print all the numeric digits contained in the string, 1 character per line. Same thing as 1 and 2. If you can figure out how to do those as index of, number 3 is trivial. And again, I'll remind you, you can only solve these problems in terms of what I've already taught you. That means no substrings. I haven't taught you substrings yet. And I know some of you have had some of the stuff before. I asked the questions in the order that I asked them for an important reason. I want you to problem solve based on what tools are in your toolbox, not what tools you will eventually learn. There are easier ways to do most of these things. Trust me. Okay? You just aren't allowed to use them yet. All right? So 1, 2, and 3 are all the same question. If you could figure out how to do 1 with the index of method, 2 and 3 would be trivial. They're almost identical methods, all 3 of them. Number 4, on the other hand, a little bit more difficult. Number 4 is called process expression. This method is going to take a string as a parameter. The format of the string will be some integer followed by either a plus sign, a minus sign, a multiplication sign, or a division sign, followed by another integer. Okay? Now, this is a regular expression, this thing here, how I've notated it. So that's why I gave you some examples over here. So the smallest expression you can have is a single integer. Or you can have an integer followed by a plus, minus, times, divide, and an integer. Followed by another plus, times, divide, and another integer. Okay? So you have at least one integer, and for each additional integer, you'll have an operator. So you can have 125. That's a possible input. Or you can have the string 125 plus 7. That is an integer followed by one of our operators followed by another integer. Or you can have 125 followed by a plus, followed by a 7, followed by a minus, followed by a 2. Make sense? Okay? So this is the format that guy's in. Your method should process this expression and return the result as an integer. Okay? You must solve this problem using only the tools you were taught thus far in the course. Okay, that's fine. So for instance, and you don't have to worry about orders of operation, just left to right. So if you don't have any math to perform, Just spit it out as the number, 125. If you do have math to perform, you need to take 125 and add to it the 7, giving you 132. Make sense? 125 plus 7 minus 2, giving you 130. So we're still going left to right. So you're going to have to walk through this string one character at a time. One character at a time. Ultimately, getting your pieces of the math problem and then doing the math. Now, having said that, I need to be a little bit... Let me quickly show you about string concatenation. You'll find that handy here. Only takes 2 seconds. String S is equal to hello. String S2 is equal to world. System.out.println S concatenated with S2. The plus sign, when applied to strings, is treated as the concatenation operator. That is, it is used to glue strings together. So this will take whatever S boils down to, which is hello, concatenate onto that whatever S2 boils down to, which is world, and spit out hello world as one string. Oh, it's my little hint down here is causing an error. There we go. Okay? And that could be permanent if we put it inside of a variable. So I can say string S3 is equal to S concatenated with S2. And then I can say print out S3. Make sense? If you want there to be some spaces in there, I can say S concatenated with the space concatenated with S2. That'll put hello space world. Make sense? Okay. One extra thing here that you will find helpful in this assignment. Trying to make this a little bit easier. Let's say that I have int a is equal to 5. And I want to turn that into the string 5. I can say string S4 is equal to the empty string concatenated with A. A is an int. This guy is the empty string. Since there's a string involved, the plus sign is treated as concatenation. So this will produce the string 5. Because A boils down to the literal 5. We're taking that literal, we're concatenating it onto the empty string, which will produce for us the string representation of 5. Make sense? Okay. Now, give me one more minute, because I'm going to give you a hint on how to do number 4. Number 4 is a hard problem. If you solve 1, 2, and 3 the right way, they should take you 10 minutes. You might spend 2 hours figuring out the first one, and then the other 2 will take you 30 seconds apiece. So the same method. But hopefully I've given you some good hints there. Now, for number 4. Let's just look at an example like the second one here. Okay? You have 2 numbers you need to add together in this case, but you don't know that. By glancing at it, you can tell that as a human. But what you're going to have to do is you're going to be reading in this entire string, the string 125 plus 7. You need to walk through this string one character at a time, collecting each character. So you'll start off with an empty string. When you hit the 1, you'll collect the 1. When you hit the 2, you'll concatenate the 2 on. So now you have 1, 2. When you hit the 5, you'll concatenate the 5 on. Now you have 1, 2, 5 in a string. Then you'll hit the space. When you hit the space, you know you have finished collecting your first number. Skip past the space. So if s.charat, whatever the current index of, is equal to the space, single quote, space, single quote, the space character, if it's equal to that, skip past it. Next thing you know you're going to be capturing is your operator, right? Plus, minus, times, divide, one of those. You'll capture that into another variable probably called op. If you have an operator, you know for a fact you'll have another number. So what are you going to do? You're going to capture that second number, just like you captured the first number. After you capture 2 numbers and you have an operator, you can do the math. Okay? The hard part in this question, besides what I just explained, the other hard part of this question is dealing with converting a string to an integer. I'm going to take mercy on you. Remind me next class. I will show you how to do this the hard way, the way I intended. I'm going to give you a tool you can use that will automatically convert an integer into a string into an integer. So if you have the string 125 like that, int s is equal to Integer.parseInt. I'm sorry, not int s. It's called int a. Int a is equal to Integer.parseInt s. What this will do is this parseInt method takes a string representation of a number as a parameter and spits out the integer version of that. Okay? And to show this to you, I can say system.out.println s plus 1. And I can say system.out.println a plus 1. In this first one, s is a string. So the plus sign is treated as a concatenation operator. So this will display 1, 2, 5, 1. In this one, a is the integer version of s because I use the parseInt method to convert it. So when I say a plus 1, it'll treat it as math. So it'll print out 1, 2, 6. That makes sense? So if you have built up a number inside of a string, you can quickly convert that number version of string into an actual integer like that. Make sense? So another tool. That means the hard part of this assignment will be walking through that string, collecting the pieces. Then if it's a multiplication sign, do multiplication. If it's an addition sign, do addition. So on and so forth. Make sense? All right. And then the paper is in there too. See, 3 to 5 page paper discussing problem solving as related to technology. Specifically discuss when it's appropriate to use existing tools like Excel to solve a problem versus writing your own software to solve a problem. So approaching computer programming from an IT perspective. When is it the right thing to use an existing tool that's already out there to solve a problem? When should you take advantage of your programming skills to write your own tool to solve a problem? Okay, so the question has you dealing with the right tool for the job. Go ahead.
Sorry, can you repeat that again?
Well, I mean, it's on Angel, but so discuss problem solving as it's related to technology. Specifically discuss when it is appropriate to use existing tools like Excel to solve a problem versus writing your own software to solve a problem. Okay, so as an IT professional, you're going to be solving problems all the time. And when you go to solve a problem, you want to use the correct tool to solve the problem. So one of the things you're going to have to go through is figuring out, how do I solve this problem? Do I go and do I find an existing tool that's out there, like Excel, for example, to solve the problem? Or do I create my own tool to solve the problem? Give me an example of when this would be the better choice versus when this would be the better choice. Make sense? All right. I will see everybody next Wednesday.